Hello everyone, my name is Prabhu Avula and today we are going to discuss about a simple program that generates quadruples for a given arithmetic expression using the Lex and Yacc languages. Now, before we get into the program, we have to understand what a quadruple is. A quadruple is nothing but a structure that has four parts, hence quad. It has four parts. The first part is an operator, whether it's a star operator or a plus operator or the minus operator, the hyphen operator, the division operator. Regardless of which operator it is, any operator comes under that. The second is argument one. The third part is argument two. Here we pass along whatever arguments we want to compute the operations on. So for example, we would want to pass variables or constants under the arguments, and both of those would be acceptable under the arguments. And finally, after the operations are done on our arguments, the final output is stored in a result. That is the fourth and final bit of the quadruple structure. So we have the operator, the argument number one, argument two, and result. Now, in order to achieve this quadruple program, we split it into two parts. The first is a Lex file and the second is a Yacc file. In the Lex file, we give all the parameters that we need. For example, here uh, we've we've said hash include y.tab.h. This will come in handy when we're executing our file. Also, as you can notice here, we have given uh, a few more instructions saying that anything that is a small letter or a number are valid for as are valid as inputs. So now when you're asked to give inputs when you're running the program, either of them is accepted. Now, when we come to the Yacc file, here is where we actually write the code that we want the compiler to understand. Now, as you can see here, we've defined a bit called quad. We've defined this little block of code called quad. Oh, whoops. Um, Here you can see OP, arg1, arg2, and result. These are nothing but OP stands for the operator, arg1, argument 1, arg2 stands for argument 2, and the result is the output of both the arguments. That will be stored in the result and that will be printed at the end. Now, we are going to work with two operators in specific, that is the plus operator and the star operator. Now, before we get into this, we need to understand that in computer science, all of the mathematical operations have preferences. Starting from left to right, the preferences goes like parentheses, followed by multiplication, followed by division, addition, and then subtraction. So in this case, regardless of whatever arguments we're passing first, the star operation will get computed first. All the star operations in the arguments that we're passing will get calculated first, and then and only then will the compiler go on to make the plus operations on each of the arguments. So it's important that we understand uh, the preferences of the operators in computer science, because or else this wouldn't make any sense. So here we can see that under plus we've assigned the operator as plus, and then we've asked for the input for argument 1 and argument 2, and the result will be computed and will be stored in the result variable. Same goes for the star operator. We have assigned the star operator to our variable OP. We've asked for inputs for argument 1 and argument 2, and the final output will be stored in the result variable, and it will finally be printed here. As you can see, these print statements here, and finally this final print statement here, it prints the final quadruple table that we actually require. Now, Lex files are saved as .l at the end, Yacc files are saved as .y at the end. Now, what you can do is you can hit Control S to save, and they will be saved For me, they are saved in this folder here on my desktop. I've named the folder cd-l, and both my files are saved here. Now, let us see if this executes. Open your terminal, command prompt terminal. In Linux, it's called terminal. And you want to navigate towards the directory in which you have your files. So in my case, I would want to go to the desktop first, and then I would want to go to the folder cd-l because that is where my files are. Now these are case sensitive, so make sure you hit the correct letters, the correct spelling and the correct case when you're writing your commands. So hit enter. Now it is in the directory in which I want, where my files are. So now we want to type lex space file name, which in this case is quad.l. Hit enter. That's done. Now we hit yacc space -d quad.y. This will compile our yacc file as well. Hit enter. Now it doesn't tell us in the command prompt that they've compiled, but if you really want to make sure, you can double click where your folders are and you will see a couple new files have been created. These three files have been created. That is what actually happened when we passed those two arguments. This is proof that they're compiled and they're ready to be executed. Now, when you want to execute, you have to type gcc space lex.yy.c space y.tab.c space -w. This is the command to execute whatever files are in that folder. Hit enter, it executes, good. And now we type the age-old command for executions in Linux, which is dot /a dot out. Click enter, and now it just takes you to the next line. It's basically asking you for an input. So now we have to give an input argument. Let's just say a plus b plus c star d. Okay, hit enter. As you can see here, it has computed it, and we can see that there are 5 quadruples in the argument. And that makes sense because for the plus operator, the first operations it's done is a plus b, and the result, it stored it back in a. And the next one would be the star operator. In the star operator, it did c plus d, c star d, and it stored the variable back in c. And finally, since now that the values of a and c have been updated, it can finally finish its operation by adding both those values. Hence, the final step is a plus c, and the final result is itself stored in a. So as you can see, this bit here is the quad table. The first column is, of course, the operand. Here we can see that the first time it executed, it went through with the plus operation. The second time it went through with the multiplication, the star operation, and the third time as well, it went through with the addition operation for each of our arguments. And the second column here has our argument 1, the third column here has our argument 2, and the final column has our result from each of the previous 2 arguments. So yeah, that's how we write and execute our codes for generating quadruples for the given arithmetic expressions, which in this case is the plus operator and the star operator, in order to generate a quadruple table. I hope this was helpful. Thank you very much.